Hello friends, today we are going to derive Schrodinger wave equation. So this wave equation can be derived using the concept of a standing wave. Now let us consider a wave traveling in direction x. Let us consider a wave traveling in direction x having amplitude xi and velocity u. Now for this wave we can write the equation as dou square xi upon dou x square at constant t is equal to 1 by u square dou square xi upon dou t square at constant x. Let us consider this as equation 1. Now in order to solve this equation we need to separate the variables. So xi of x comma t can be written as xi x into xi t. Now since this is a wave equation, so time function should be taken in such a way that it is periodic in nature. So time function should be taken in such a way that it is periodic in nature. It is periodic in nature. And we take time function as xi t is equal to sine of 2 pi nu t, where nu is frequency of the wave. Nu is frequency of wave. Take this as equation 3. Now if we put equation 2 and equation 3 in equation 1, we get put equation 2 and equation 3 in equation 1. We get dou square xi x sine 2 pi nu t upon dou x square is equal to 1 by u square dou square xi x sine 2 pi nu t upon dou t square. Now differentiating this, we will get sine 2 pi nu t dou square xi x upon dou x square is equal to 1 by u square minus of 2 pi nu whole square upon we have already taken u square, so minus 2 pi nu square sine 2 pi nu t into xi x. Now when we cancel out this sine 2 pi nu t to sine 2 pi nu t, we get dou square xi x upon dou x square is equal to minus 4 pi square nu square upon u square into xi x. This minus sign will be at outside, not inside this bracket. This minus sign will be outside this bracket. Now consider this equation as equation 4. Now if we take u is equal to lambda into nu, where lambda is wavelength of this wave and nu is frequency, and substituting this in equation 4, we get dou square xi x upon dou x square is equal to minus 4 pi square nu square upon lambda square nu square into xi x. Now if we cancel out this nu square with nu square, we get minus of dou square xi x upon, sorry, not minus of dou square xi x, dou square xi x upon dou x square is equal to minus 4 pi square upon lambda square into xi x, right? Now we take this equation as equation 5. Now if we write lambda is equal to h upon px and substituting this in equation 5, we get dou square of xi x upon dou x square is equal to minus 4 pi square upon h square px square xi x. Consider this equation as equation number 6. Now total energy of this system, now total energy of this system is Ex is equal to Tx plus Vx, where Tx is kinetic energy and Vx is potential energy. Now we can write this as Ex is equal to Px square upon 2m plus Vx. Tx is equal to half m Vx square and Px is equal to m Vx. So solving these two, we get Tx is equal to Px square upon 2m. Now we can write this Px square is equal to 2m into Ex minus Vx. Now substituting the value of Px square in equation 6. Substituting this value of Px square in equation 6, we get dou square xi x upon dou x square is equal to minus of 8 pi square m upon h square into Ex minus Vx into xi x. Rearranging this, we get dou square xi x upon dou x square plus 8 pi square m upon h square into Ex minus Vx xi x is equal to 0. So this is Schrodinger wave equation. This is Schrodinger wave equation in one dimension. This is in one dimension. Now if we extend this, equation, this equation in 3 dimension, we get dou square xi upon dou x square plus dou square xi upon dou y square plus dou square xi upon dou z square plus 8 pi square m upon h square into E minus V xi is equal to 0. So this is Schrodinger wave equation in 3 dimension, where E is total energy of the system and V is total potential energy of the system. Now if we multiply this equation, by, if we multiply this equation by minus of h square upon 8 pi square m, we get minus h square upon 8 pi square m into dou square upon dou x square plus dou square upon dou y square plus dou square upon dou z square xi, we have taken xi common, plus v minus e xi is equal to 0. Now rearranging this equation, we get minus of h square upon 8 pi square m del square plus v into xi is equal to e xi, where del square is Laplacian operator, and its value is, del square's value is dou square by dou x square plus dou square by dou y square plus dou square by dou z square. We can also write this equation in Hamiltonian operator terms. So we can write this as h xi is equal to e xi, where h xi, so where h operator is Hamiltonian operator, and its value is minus of h square upon 8 pi square m, I missed the pi square here, pi square m del square plus v. So this is value of Hamiltonian operator. I hope you love this video, and don't forget to like this video and subscribe to my channel Gaurav Gurukul. Thank you.